Hi everyone, in this video we are going to understand what fine-tuning is and how you can fine-tune a Mistral model for your specific use case. So let's start with the definition of fine-tuning. Fine-tuning is a machine learning technique where a pre-trained model is further trained on a specific smaller data set to customize it to a particular task. It is the process of updating the weights of an LLM to update its knowledge. So basically, you teach more things to the model than it already knows. By fundamentally altering the model, instead of only a prompt specific change in knowledge or responses, like for example, like prompting techniques or RAG. It is very similar to how humans learn new things. Think of it like a medical student with general medical training who then specializes in a specific field like cardiology. So, why and when should you fine tune instead of going for other methods like RAG? First of all, I would suggest you start with as detailed a prompt or context engineering as possible. That is a good starting point. But if you continue doing it and if your usage increases, you might hit a wall eventually. That is when fine tuning comes in. So this following blog on the Mistral website, it shows the common use cases for fine tuning. Let us discuss a few of them in more detail. The first one is to set a particular tone or style. For example, let's say you're building a customer service chatbot that should consistently use a particular style or tone. We will also see this in our example of building a counseling chatbot that comes with a more conversational and empathetic tone than the usual responses given by an LLM. The second one is specializing the model for a particular domain, for example, like a legal document summarization. The third one is reducing cost and latency by using a smaller yet efficient fine-tuned model. This can also lead to savings in carbon footprint. Now let us see some examples for these use cases. So our first use case was setting a specific tone and style. Now if you see in these examples, this is a customer service chatbot and you can compare the responses before and after fine-tuning. Let's take the first one. Your refund is under review, you'll get an update soon. And here, but after fine-tuning, you have a more welcoming message with more information. So if you see it on the right, the message is giving concrete action points instead of just saying that, okay, you will get an update. So the next one is the same, it's more welcoming and it is also more helpful because it's asking if you want to change the plan, I can change the plan. And the last one is again in another language, which is Hindi, and it's giving more concrete information that the request will be processed between 2 to 3 days, and if it doesn't, then they will help the customer. So you might ask me, can we not achieve this kind of tone and style through prompting? Yes, of course you can by providing few short examples, but it is not 100% reliable. I mean, fine tuning is also not 100% reliable, but it is definitely more accurate than prompting and more reliable in the sense you know that LLM outputs are non deterministic. I mean, for the same input, at different times you get different outputs. So when you fine tune a model, it is more likely to match your expectations. So this is the first use case. So the next use case is to build domain specific models. Fine tuning can be used to customize an existing LLM with generic knowledge to a specific domain, like in healthcare. Let us consider the example of radiology. Let's say the user gave a query about their radiology report. Before the fine tuning, a generic model will say something like abnormal lung growth. It could be benign or malignant. But after fine tuning, you can see that it gives more details and also the next step. And it's the same for tax queries and also legal queries. For example, if you see here the query is gift from a sister or a family member taxable according to the Indian law. Before fine tuning, it says gifts are sometimes taxable, but after fine tuning, it gives the specific section which gives details about the taxes on gifts from family members or siblings. And the same goes for the legal queries. These are some of the domains I've listed here, but fine tuning can be used for any domain like customer service or astronomy or agriculture and so on. Now, let us talk about the cost and efficiency aspects of fine tuning an AI model. So, let us consider a scenario where you are building a full customer service AI agent with complex workflows. This requires an advanced version of prompt engineering called context engineering, where you need to provide a long system prompt with specific instructions, context from the web, context from web search or memory, tool descriptions with all the parameters and schemas, and also a few short examples inside every request, and also the user query. So in the first case, with just prompt engineering or context engineering, you send all these details to the API, and when you count the tokens, the prompt alone could cost up to 1350 tokens just for one query. So, so after fine tuning, the model already knows the style, and it doesn't really need to go and fetch the context from web, and it also has the knowledge of the tools that need to be called and also their respective parameters and schemas. The since the style is already baked into the fine-tuned model, the few short examples are also not needed. But sometimes you might want to add memory, that is the previous responses. So and that could make up some tokens, and approximately you can perform the same action with a fine-tuned model in 50 to 100 tokens. That means we save around 1250 tokens per request, which is a significant cost reduction. And it also reduces the response time because the model now has to process fewer tokens. See, if your requests are rare, your cost might be low. But if you want to scale your AI application with up to, let's say, 100 requests per minute, the API cost can quickly add up. You have to make a trade-off between the API cost and the cost of using a fine-tuned model. And more often than not, it is the fine tuning and more often than not, it is the fine tuned model that is more economical. So this is exactly why organizations fine tune instead of using external APIs and feeding them massive prompts repeatedly. It is much faster, cheaper, and also more consistent. So now I now hope that you understood the utility of fine tuning and when it is most suitable. There are different ways of fine tuning, full fine tuning or fine tuning with LoRA or QLoRA, but we will go through them in other videos. So let's talk about the specific use case that we are going to use fine tuning for. So across India, a large number of students a large number of students they struggle with exam pressure, especially during the preparation phases for competitive exams like NEET, UPSC, IIT. And the cases of anxiety and loss of confidence are common, but students usually do not seek help like for various reasons. Like counseling can be expensive, and there's also this social stigma. And there are online solutions, but most support is available in English. So, to address this accessibility gap, here we are aiming to build a Telugu language emotional support chatbot for students, especially designed to handle diverse scenarios from everyday stress to academic setbacks. So, so this is a short demo dataset that I will be using to show you how to fine tune a Mistral model with this dataset using their API. So it has approximately 10K plus counseling style conversations so that the models can learn how to give more culturally appropriate, empathetic and psychologically safe responses that feel closer to how a human counselor would respond in real life. So a short disclaimer, this current system and dataset, they are built only for demo purposes, and this is not a production grade mental health dataset, and it must not be treated as professional or medical advice. However, if you require a high quality production ready counseling dataset in Indian languages or any other language, or for an entirely different use case, you can certainly request or order a custom dataset through DataCreator AI. So now that we've understood the problem statement, let us go through the data set and examine one or two conversations. So for fine tuning, all the typical steps that are involved in a machine learning process are still applicable. And the first step of any model training is to prepare the data set. So this is the official Mistral blog where they mention the specific format in which they are expecting the data. So fine-tuning since we are fine-tuning for a chatbot, the conversations should be in this format. So each conversation should be enclosed in a messages array, and the first turn is the user's turn where the user says something and the assistant replies, and it keeps alternating between the user and assistant. And the rule is that the final turn should be taken by the assistant. The conversation should end with the assistant role. So this is the JSON format that the conversational dataset should follow. Now let us take a look at the chatbot dataset. So like I said, it is in Telugu, but you don't have to worry. I will translate it to you. And the same principles and the same method can be applied to fine tune the data, to fine tune the models with similar conversations in other languages as well. So basically, in this conversation, the student is expressing some disappointment and concern that he's not able to get good marks even after reading a lot of NCERT books for his entrance exam. And the assistant is consoling him, saying that it's not just enough to read the book, but it is also essential that he solve some practice papers. He and the user says that he's focusing more on reading than practicing, and then the assistant guides him that time management is very important, and he should spend at least 2 hours every day solving practice papers. And the user then expresses concern that while practicing he's making a lot of mistakes, and then the assistant offers a compassionate response, saying that mistakes are common and it is important to analyze them and learn from them. And the assistant finally encourages them to focus on the topics that they are not very comfortable with, and it ends with a more supportive message. So this is basically one of the conversations from our dataset, and the entire dataset is structured like this. So this structure is a readable JSON structure for us to understand. But while training the model, it should be in a JSONL format. This is a JSON format, but the fine tuning requires the dataset to be in .jsonl format, which is nothing but each conversation. I mean each of these conversations in this entire conversation dataset should be on one line. I'll show you one of the JSONL datasets, how it looks. So this is how a JSONL dataset looks. So each message's conversation is on one line. So these roles of user and assistant and this format and the JSONL file format, these are all common for most providers. And one more one more important practice is that it's best to divide your data set into train, valid, and test. So the training data set is further divided into train and valid. 80% of the data set goes into the training file, and 20% can go into the validation file. So you can also split your dataset as 70% for training, 20% for validation, and 10% for test data. Or you can keep this 80-20 split and come up with a new test dataset to test this fine-tuned model. So this dataset was built using a combination of synthetic data generation and also human review. So fine-tuning with this will change the kind of conversation that people can have with an AI model. So instead of a long monologue, it will be more like chatting with an actual person. So before you can get started with the fine-tuning, you first need to upgrade to the scale tier to have access to the fine-tuning API. I'm already subscribed, so I see this unsubscribe button. But when you click on subscribe, you can add your payment method and then add the credits to get started with the fine tuning. There is also one advantage where your API requests and your data won't be used to train the AI models. So it is safe to upload proprietary datasets. Now once you have upgraded, you can go to the Mistral AI Studio, and if you scroll a little bit down, you can see this fine tune a model option. You can just click on it and you can set all the data set, and then here you can add your data sets and set the parameters and then launch the training. So first let's start with the model type. It can be either a completion model, which is a text generation model, or a classifier. Here we are training an LLM, so it will be completion. We will see how to build a classifier in some other video. So select completion and then we come to the base model. So here you can see all the models that you can use for fine tuning, and if you hover over any one of the model, you can actually see the cost for input, output, and also the training. So if you see for Mistral, it is $1 per a million tokens, and it's the same for Mistral 8B, and it is slightly more expensive for the larger models. Here I have chosen the Mistral model because it is a highly powerful edge model, and in our use case it is very specific. It is for an emotional support chatbot, so you don't really need you don't really need a huge model for this. So based on this use case, I have selected that 3B would be sufficient. So the advantage with the smaller models is that they are faster and also cheaper, as you can see. So once you've selected your base model, then you can add your training datasets and validation files. So I've already added them, so I can select the training dataset in the JSONL format and also the validation. So now that we've added these, since I've already uploaded them, I've just added them directly. You can click here and you can drag and drop, or you can add your own. So if you want, you can directly upload from your computer, and the maximum size of the dataset that can be added is 512 MB, and for the validation dataset, the maximum size is 1 MB. So one more advantage with this is that when you upload a JSONL file, if it's not in the correct format, that like how we have discussed, like the valid roles and the alternating between conversations, if it is not valid, the system will prompt you here itself. Maybe I can just show you. I will add a training file with the roles that are incorrect or empty, and I'll just upload it. So here you can see that it's immediately showing that there is a validation error and one of the roles is invalid, and the valid roles are only system, user, and tools. So I think you have understood how to add the files. Now let's go to the next step. So these are the parameters that you can change. So the first one is the learning rate and the epochs. So the learning rate is the speed at which the model learns, like how big each correction step is when the model is improving itself. If it is too high, the model runs too fast and it keeps overshooting the right answer. And if it is too low, it takes forever to finish the fine tuning. The, the Mistral blog, it recommends this default learning rate, and this default learning rate, it follows a schedule of warm up and a decay. So first it increases and then there is a cosine decay. And in modern ML, especially with transformers, this warm up plus cosine, it has become the default because it is more stable and accurate. So here we are using the same recommended default, and the epochs is the number of times the model sees your entire dataset. It is the number of times the model reads your dataset. So once you have fixed these parameters, then you can click on next, and these are the recommended ones. And for epochs especially, it's better not to go beyond 5 because again that could lead to overfitting. So then click on next. So on this screen, the system shows you the final confirmation before starting the fine tuning job. So you first see the number of tokens you have uploaded, and then how many steps are there, and in each step how many tokens are being processed. And for the entire training, this is the number of tokens. And obviously I have added only these many tokens for demo purposes, but the more diverse and the more high quality your data set is, the better it is. And it also helps if there are more number of tokens, especially because since this is a 3 billion parameter model, it is best to have many tokens. And here I have only added 1.4 million tokens for this fine tuning demo. And then you get the expected duration, 4 minutes, and also the estimated cost based on the model that you have selected. And then you can check these numbers and then click on launch training. Once you click on launch training, your job will be queued and you can see your training parameters and how the loss is being reduced or how the model is learning here in this metrics place. So basically the step is it shows the training iteration number, and the measured at is the time, and the training loss. This shows how well the model is learning step by step from the training data. A lower number is better, so if the loss is going down over steps, the model is improving. And the validation loss, this shows how the model performs on unseen data when that is not being used in the training. And validation mean token accuracy is how many tokens the model predicted correctly on the validation data set on an average. So if you see, it started at this loss and it stopped here at the 12th step. So that means there is a little bit of training loss. I mean, since this is only a demo, the number of tokens is less, the training these are the number of steps, and that is why the training has reduced only a bit. But if you add more data sets, then you can clearly see how the training loss reduces over the steps. And a validation data set is essential so that you can see if there is being any overfitting. So you know that the data set training is overfitting when the training loss is decreasing but the validation loss is increasing. This means that the model is memorizing the training data set, but it is not learning any patterns or how to generalize. So once this is done, you'll see that the job has been completed, and then you will get an ID that you can use with an OpenAI compatible API immediately. So instead of using Mistral 3B latest as your model name, what you have to do is just copy the ID here, and then you can use it in your API call. And you can also further use the same fine-tuned model to create an agent. So we will see that in the upcoming videos. For example, you can use a fine-tuning dataset to teach the, models to call certain tools with certain parameters, and after fine-tuning you can use the same to create the agent. And if you click on this job under fine-tune models, you can always see how the training took place and also all the parameters that you've given. So this is how the fine-tuning works from the UI perspective. So this is we have done this on the AI Studio, but there is also a programmatic way that you can do all these steps, but this I've shown you as a low-code option. So you can also achieve the same fine-tuning flow with the API client by installing the Mistral SDK. So with this you can also add integrations to tools like weights and biases to observe the steps in more detail. So this can help with hyperparameter tuning of learning rate and the epochs. So adding these fine-tuning jobs programmatically is useful when you want to automate this entire process or integrate this flow into some other product. So if you can see, you can call these fine-tuning jobs through the API client and experiment with various hyperparameters and integrate and visualize it in weights and biases. And then after you perform this, after this job has been completed, you can use that model to get the responses from the API. So finally, I would like to say that fine-tuning with Mistral API or the AI Studio, it can save you a lot of time and also cost. So this is the best option for small and mid-scale fine-tuning instead of renting the GPUs and setting up everything by yourself. In the upcoming videos, we will go deeper into fine-tuning, agent building and much more. Thanks for watching.